Yes. Hello friends, welcome to the session. Now see the what is now see the some classroom workbook questions based on chapter 2, that is error analysis. Okay, all of you take the workbook. Yes, this is topic is error analysis. The topic is error analysis. Chapter is same and topic is also error analysis. See the first question. All of you read the first question. Quick. Yes, what it is given? A 0 to 150 volts voltmeter having accuracy of plus or minus 1% of full scale reading. What it is given? A 0 to 150 volts voltmeter having accuracy of plus or minus 1% of full scale reading. Then percentage limiting error. You want to calculate percentage limiting error in the measurement of how much? Yes, in the measurement of 30 volts. It is asked. In the measurement of 30 volts. Then what is the solution for this problem, you tell me? Already given the formula. How to calculate percentage limiting error? Percentage limiting error equal to full scale reading by full scale reading by true value into plus or minus percentage accuracy at full scale. This formula you know. Plus or minus percentage accuracy at full scale. Yes. Therefore, percentage limiting error equal to what the full scale reading is given 150. What the true value is given 30 volts. What the accuracy at full scale plus or minus 1%. Then what the percentage limiting error equal to get plus or minus 5% we can get. Clear? Concentrate. Quick note down. Yes, see the question number 2. Concentrate, see the question number 2, what it is given. Yes, a 0 to 50 volts voltmeter having accuracy of plus or minus what it is given 2% in the measurement of what it is in the measurement of 20 volts. Calculate percentage limiting error. Calculate percentage limiting error in the measurement of, you want to calculate percentage limiting error in the measurement of 40 volts. This is asked. Given voltmeter is which one? Yes, it is a 0 to 50 volts voltmeter. Okay. That means a 0 to 50 volts voltmeter having accuracy of what it is given, having accuracy of plus or minus 2% in the measurement of 20 volts. Then calculate percentage limiting error in the measurement of 40 volts. It is given. That means here plus or minus 2% is given in the measurement of 20 volts. That means given error is which error? Percentage limiting error is at 20 volts. Then we calculate percentage limiting error at 40 volts. We can solve this problem in two methods. See, one method I am explaining like this. Method 1. Okay. Here it is given with respect to true value now. That's why taken as a limiting error. I want to calculate what is accuracy at full scale to get the limiting error at 40 volts. How to calculate accuracy at full scale? You know this formula now? Yes. Percentage limiting error equal to full scale reading by true value into plus or minus percentage accuracy at full scale. Percentage accuracy at full scale. Yes. Percentage accuracy at full scale. Now, what is the percentage limiting error is given? Yes, 2%. What is the full scale reading? 50 volts. What is the true value in the measurement of 20 volts? What is the accuracy at full scale? You want to calculate. Plus or minus percentage accuracy at a full scale. Clear? Now from this, what is the accuracy at full scale? Accuracy at full scale equal to, yes, accuracy at full scale equal to plus or minus, this how much we get? This is 40 plus or minus 40% by 50. How much you get? Plus or minus 0.8%. This is accuracy at full scale. But this is not the question asked. You calculate limiting error at 40 volts. What is the percentage limiting error at 40 volts? Percentage limiting error at 40 volts equal to, yes, same formula. Full scale reading by true value into plus or minus percentage accuracy at full scale. Na? What the full scale reading is given? 50 volts. What is the true value at 40 volts? What is the accuracy at full scale? Plus or minus 0.8%. Okay. Then how much you get? You get at 40 volts. How much you can get? This is error at limiting error. This is error at full scale. You want to calculate at 40 volts. Then how much you can get? You tell me. That is plus or minus 1% we can get. That means by using same meter, we are getting the error at 50 volts. How much error we are getting? Plus or minus 0.8%. At 40 volts, what is the error we are getting? Plus or minus 1%. At 20 volts, what is the error is given? Plus or minus 2%. Pointer is moving away from the full scale reading, na, error is increasing. If the pointer is moving towards the full scale reading, na, error is reducing. Yes, whatever the answer is there, that is correct. Okay, this is method 1 you can solve. Simple. You calculate accuracy at full scale, that you substitute here, then you can get the limiting error at a given value. Or otherwise, the same problem we can also solve like this, method 2. Yes. What is the percentage limiting error equal to? You know this one. Percentage limiting error is inversely proportional to true value. That relation in the observations I given. Then how to solve percentage limiting error at you want a percentage limiting error at 40 volts na, by percentage limiting error at 20 volts is equal to inversely proportional true value of what is the true value? That is 20 volts. What this one? 40 volts. Inversely proportional you take. Then what is the percentage limiting error at 40 volts equal to? 40 volts equal 20 by 40. What is the percentage limiting error at 20 volts is given? Plus or minus 2%. Then how much you get? Plus or minus 1%. Like this also you can solve. Okay, quick. This method 1, method. What are the method you convert? That method you follow. This is a question number 2. Quick note down. See the question number 3. Yes, all of read the question. What it is given? Yes. Read. Yes. Given that a 0 to 20 ampere ammeter, a 0 to 20 ampere ammeter having accuracy of how much it is given? Having accuracy of plus or minus 2% of full scale reading. Plus or minus 2% of full scale reading. Then in the measurement of 10 amperes, the range of current measured equal to dash. The range of current measured equal to dash. This is the question asked. The range of current measured is dash. A 0 to 20 ampere ammeter having accuracy of plus or minus 2% of full scale reading. In the measurement of 10 ampere, the range of current measured is dash. Then you want to find in what range we can measure. Okay. I told already, wherever you want to find the range of measured value, I given one formula, AM equal to AT into 1 plus or minus epsilon. Use that formula also, you get the answer. But no need to use that, directly also you can solve. Given that plus or minus 2% of full scale reading, then I want to calculate first absolute error at 20 amperes. Absolute error at 20 amperes. Okay, what is the absolute error at 20 amperes equal to? Because this error is at full scale now with respect to 20 amperes is given. Then 20 into plus or minus 2 by 100. Then how much you get? Plus or minus 0.4 amperes. Once you know the absolute error at 20 amperes, absolute error at 10 ampere also 0.4 amperes now. It is also equal to absolute error at 10 amperes. Absolute error at 10 amperes. Because absolute error is a constant error. No sir, I want to calculate separately for absolute error for 10 amperes means. Then another way is calculate limiting error at 10 amperes. Limiting error at 10 amperes. Then you calculate absolute error at 10 amperes. We can get same answer. That no need to do that one. You calculate according to this. You calculate limiting error at 20 amperes. This absolute error is same for 10 ampere also, because absolute error is a constant error. Now, what is the range of current measured? You tell me. Range of current measured. Yes, range of current measured equal to whatever the current we are measuring. For that current, we can add this absolute error. 10 plus or minus 0.4. Then what we can get? 9 point. Yes, what do you get? 9 point. That is 9.6 amperes to 10.4 amperes. 9.6 amperes to 10.4 amperes. Then which option is correct? Answer is C. Option C is correct. Understood. Then for this, what is the option I given? This option B is correct. Okay. For this, I think no options, no? Okay. This is question number 3. Concentrate quick. Just one point to remember. Wherever the range of measured value you are calculating, it may be ammeter or voltmeter, wattmeter, whatever it is given. Wherever the range of measured value you are calculating, you calculate absolute value, absolute error, then you can add that absolute error to value to be measured, then that gives the range of measured value. These are the measured values. This is the true value. This is the full scale value. See the difference. This is full scale value. The value to be measured is true value. After measuring, what is the value you are getting? This is the measured value. Okay. See the question number 4. All of you read the question. Yes, read the question. What it is given? Yes. A 0 to 100 volts voltmeter. A 0 to 100 volts voltmeter. Yes, having accuracy of plus or minus, having what it is given? Yes, having class 2 accuracy. Having class 2 accuracy. Having class 2 accuracy. A 0 to 100 volts voltmeter having class 2 accuracy. What the class 2 indicates I told already. Plus or minus 2% of full scale reading. Having class 2 accuracy. Then, yes, calculate what it is given? Percentage limiting error and absolute error. What it is given? Absolute error in the measurement of, yes, in the measurement of how much? In the measurement of 75 volts it is given. Calculate percentage limiting error and absolute error in the measurement of 75 volts. Okay. This is a question in this problem. This is a question. Clear? What the percentage limiting error and absolute error in the measurement of 75 volts? What the percentage limiting error equal to full scale reading? Full scale reading is how much? 100 volts. By true value 75 volts. Percentage accuracy at full scale, how much it is given? Plus or minus 2%. Plus or minus 2%. Okay. This you simplify this, what you can get? 4 by 3 into plus or minus 2%, that is plus or minus 8% by 3. Plus or minus 8% by 3. How much you get? Plus or minus 2.66%. This is a percentage limiting error. You also calculate absolute error now. How to calculate absolute error? I told already. Absolute error equal to, yes, absolute error equal to percentage limiting error of true value. Percentage limiting error of true value. What is percentage limiting error? Plus or minus 2.66 by 100 into what is the true value? How much we are measuring? 75. Okay. This gives the absolute error. Plus or minus percentage limiting error of true value. Limiting error is 2.66%. 2.66 by 100 into 75 volts. This, you simplify this, how much you get? Plus or minus 2.66 by 4 into 3. This, we simplify this, we can get, this is the absolute error. What is the B question here? Calculate percentage limiting error in, yes, what given? Yes. Calculate percentage limiting error at a half full scale deflection. What is the percentage limiting error at half full scale deflection? Half full scale means, this is 100 na, half full scale means 50 volts. That means you want to calculate percentage limiting error at 50 volts. That is 100 by 50 into, what the error at full scale is given? Plus or minus 2%. Then how much you can get? Yes, sir. Full scale reading by true value into accuracy at full scale. Then how much you get? Plus or minus 4%. Yes. Simplify this, you get answer, and this is B question. Quick note down. This is the fourth question. Okay, read the fifth question, all of you. See the question number 5. What it is given? Yes, yes. For the circuit shown in figure, calculate power dissipated by the resistance. Yes. What the circuit is given? This is a circuit now. For the circuit shown in figure, calculate power dissipated by the resistance. This is a given circuit. This is I, and this also I. How much I it is given? Yes. How much? Yes, 10 plus or minus 2%. Or the R value it is given? 4 plus or minus 1%. Okay, in this circuit you calculate the power dissipated by the resistance. Then what is power dissipated by the resistance? P equal to I square R. No? Clear? P equal to I square R. Then how to solve? P equal to I square. That what is the current? 10 plus R minus 2% square. Yes. How much resistance is given? 4 plus R minus 1%. 4 plus R minus 1%. Then simplify this. How much you can get? 10 square means 100. 100 plus R minus. This square becomes multiplying power. Na? I given already in the concept. Square becomes multiplying factor for limiting error. Na? Then what you can get? Plus R minus 4% into 4 plus R minus 1%. How much you can get? 400 plus R minus 5%. This is the power dissipated by the resistance. Clear? Quick note down. This 400 watts plus R minus 5%. You also convert this in terms of, the answer may be expect in terms of absolute form also. But here this is, you are getting answer in terms of which one? Percentage form. If you want to write answer in the form of absolute form means, what you can write? 400 into plus R minus 5 by 100. How much you can get? Plus R minus how much? 20 watts. Then what is the power in absolute form? You tell me. 400 plus R minus 20 watts. Like this also you can write. The answer may be expect either in terms of absolute or maybe in terms of percentage. Quick note down. Over. See the question number 6. Yes, what it is given? Yes, read the question. 3 resistances. What are the 3 resistances are given? R1 equal to how much? 40 plus R minus 2%. What is R2 is given? R2 equal to 30 plus R minus 1%. R3 equal to how much is given? 50 plus R minus 2%. Are connected in series. That is given that connected in series. Then the resultant resistance equal to dash. Okay, this is the question asked. Yes. What is the resultant resistance if the 3 resistances are connected in series? R equal to R1 plus R2 plus R3. Yes. R equal to R1 plus R2 plus R3. Then how to write R equal to, what is R1? 40 plus R minus 2%. What is R2? Yes, 30 plus R minus 1%. What is R3 is given? 50 plus R minus 2%. Yes, 50 plus R minus 2%. But in addition, we don't add limiting errors directly. Na? That's why first you convert into absolute form. Then what is the absolute error of this one? 40 into plus R minus 2 by 100. How much get? Plus R minus 0.8. Absolute error in 40. How to convert absolute error in 30? That is 30 into plus R minus 1 by 100. How much you get? Plus R minus 0.3. What is absolute error in 50? 50 into plus R minus how much? 2 by 100. How much you get? Plus R minus 1. So, okay. Then what is the resultant resistance? R equal to 40 plus R minus 0.8. 40 plus R minus 0.8. Then plus 30 plus R minus 0.3 plus what you get? 50 plus R minus 50 plus R minus 1. Then add this all, what you get? 40 plus 30 plus 50, 120 plus R minus. This is how much? 1.1. This 1.1 plus 1, 2.1. This is the resultant resistance. Yes. Then how to calculate? This error may be specified in terms of percentage also. Then if it is given in the option, directly you take this one. If it is not there, then you go for percentage error in R. What is the percentage error in R? Percentage limiting error in R. What is the percentage error in R? How to write? You can tell me. Plus or minus 2.1 by 120 into 100. Then you simplify this, we get the option. You check the options. If it is given in percentage or is it given in absolute. If it is there, directly you take this one. Otherwise, you convert into percentage. Clear? Understood? Okay, concentrate. This question number 6. You see this? What is the question number 7? All of you read the question. To the question, what it is given? S. The question on bridge, na? S. For the bridge circuit shown in figure, calculate unknown resistance at balance condition. That means in this bridge circuit, you want to calculate the unknown resistance at balance condition. This is the question asked. Okay, this is the given bridge circuit. This you want to calculate unknown resistance at a balance condition. Okay, this is a bridge circuit is given. This is Rx. S 40 plus or minus 1% it is given. 20 plus or minus 2% it is given. S 50 plus or minus 2% it is given. Okay, this is galvanometer. This is a given bridge circuit. Given that bridge is at a balance condition, you want to calculate unknown resistance. Okay, then what is the at balance condition product of opposite resistances are equal? In detail about this later on we'll see in the bridge. Okay, product of opposite resistances are equal means 40 plus or minus 1% into Rx is equal to this 20 plus or minus 2%. Yes, 20 plus or minus 2% into 50 plus or minus 2%. Is correct? 50 plus or minus 2%. Then what is unknown resistance Rx equal to 20 into 50,000 plus or minus. In multiplication, given is limiting error. If it is given this problem in absolute, then you convert into limiting, then you can solve. But directly is given in limiting, no problem, easy to solve. That is 1000 plus or minus 2% and 2%, that is 4% by 40 plus or minus 1%. Again we are getting division. In division limiting errors are added. Then how much you can get? Yes, 25 plus or minus 5%. Okay, like this we can solve. 25 plus or minus 5%. Clear? Concentrate. Quick note down. Let's see the question number 8. All of you read the question. Okay, what it is given? Eighth one. Yes. Given a 0 to 150 volts voltmeter. Yes. A 0 to 150 volts voltmeter. What the accuracy given? A 0 to 150 volts voltmeter having accuracy of plus or minus 1% of full scale reading. Yes. Ammeter is also given. A 0 to 10 ampere ammeter. What the accuracy given? Accuracy of plus or minus 0.5% of full scale reading it is given. Yes. Next, what it is given? In the measurement of resistance, the voltage measured is how much? Yes, 50 volts. The current measured is 2 amperes. Then you want to calculate what is the actual resistance measured. That means in the measurement of resistance, we are used 0 to 150 volts voltmeter and 0 to 10 ampere ammeter. But 0 to 150 volts voltmeter accuracy is this one. 0 to 10 ampere ammeter is accuracy is this one. But by using this meter, we are not measuring 150 volts. We are measuring 50 volts. By using this meter, we are not measuring 10 ampere. We are measuring 2 amperes only. But there is some error in the measurement of voltage na. There is some error in the measurement of current na. There is some error in the measurement of resistance also. What is that resistance value you want to calculate? How to calculate resistance, you tell me. Resistance, once you know the voltmeter and ammeter readings, how to calculate voltmeter reading, but there is some error, plus or minus some error. Ammeter reading, plus or minus some error. If errors are not there, then directly voltmeter reading by ammeter reading. But errors are given at full scale. But I want to calculate first error at 50 volts, error at 2 amperes. Then we can get the error at resistance measurement also. Now tell me, what is the percentage limiting error at? What is the percentage limiting error at? How much we are measuring? 50 volts. Then 150 by 50. What is the accuracy at full scale? Yes, plus or minus 1%. This is plus or minus 1%. How much you can get? Plus or minus 3%. Percentage limiting error at 2 amperes. How much current we are measuring by using ammeter? We are measuring only 2 amperes. Then what you can get? 10 by full scale reading, 10 by 2 into plus or minus 0.5%. Then how much you can get, you tell me? That is plus or minus 2.5%. Plus or minus 2.5%. Then you want to find what the resistance measured na? Resistance equal to voltmeter reading is 50, but error is plus or minus 3%. Ammeter reading is 2 ampere, but error is plus or minus 2.5%. Then how much R you can get? 25 plus or minus 2.5%. Okay, this is the actual resistance measured. Clear? Errors are given for full scale. You calculate the error at whatever the values we are measuring. Then you can get the error in the resistance measurement also. Clear? Understand? That you concentrate. Quick, no doubt. Yes, see this. Concentrate on question number 9. Read the question, all of you. What it is given. Yes. What 9th question? Yes. 9th one. Two resistances R1 equal to how much? 40 plus or minus 2 ohms. Yes. R2 equal to 10 plus or minus 1 ohm. Are connected in parallel. Are connected in parallel. Then calculate resultant resistance and range of resistance measured. you want to calculate resultant resistance and range of resistance measured. Two resistances are connected in parallel means what is R equal to? R1 R2 by S, R1 plus R2. R1 R2 by R1 plus R2. It's clear? Okay. But I told already in the observation, in the error due to combination of quantities, I told one observation. Don't do like this. It is in multiplication, we can get error in percentage. It is addition, we can get errors in absolute. You convert this into percentage. This is percentage, this is percentage. In division, we can add these errors directly. Like that you don't do. Why? I told in multiplication and division, limiting errors are added directly. But condition is there is no any addition term, there is no any subtraction term. But there is addition term here, na? That's why you don't add directly. Then you go for procedure. I given already procedure also how to do that. Okay. Then two resistances are connected in parallel. 1 by R equal to 1 by R1 plus 1 by R2. Go for according to concept you solve. Okay. Partial differentiate both sides with respect to R. Then what you can get? Minus 1 by R square equal to S minus 1 by R1 square into dou R1 by dou R. Yes. Minus 1 by R2 square into S dou R2 by dou R. Okay. This negative sign is cancelled. No? This is cancelled. Then what you can get? Dou R by R square equal to dou R1 by R1 square plus dou R2 by R2 square. Okay. Instead of dou, you take delta. Then what the delta R equal to? Yes, R square into yes, what do you get? Delta R1 by R1 square plus delta R2 by R2 square. Okay. First you calculate R, you tell me. What is R equal to? R1 R2 by R1 plus R2. Yes. What is R1 R2? 40 into 10 by 40 plus 10. Then how much you get? 8 ohms. Okay. You substitute all the values here. Then what the delta R equal to? 8 square into delta R1 is how much it is given? Plus R minus 2 by what is R1 square? 40 square plus what the delta R2 it is given? Plus R minus 1 by what is R2 square? 10 square. Okay. Take plus R minus is common. What you get? Delta R equal to plus R minus 8 square by 40 square plus 8 square by 10 square. Simplify this. What do you get? Tell me. This is 2 into 8 square by 40 square. Then how much delta R you can get? Plus R minus 2 into 64 by this is 40 into 40 plus 64 by 100. Then what you get? Delta R equal to plus R minus this how many times? This is 4 4 16. This is 4 times. This is 8. That is 0.08 you can get. Plus it's correct. 16 4 4 16 4 times it goes. 8 by 100 that is 0.08. This is how much? 0.64. Then how much you get? Plus R minus 0.72 ohms. This is delta R. Then you want to find what the range of resistance measured. First you calculate what the resultant resistance you tell me. Therefore, the resultant resistance equal to 4 plus R minus 0.72 ohms. This is the resultant resistance. But what it is asked, you also calculate what is the range of resistance measured. Then how to calculate range of resistance measured? Yes, range of resistance measured. Range of resistance measured. What it is given? How to get range? 4 minus 0.72 ohms to you can add one, subtract one time and add one time to 4.72 ohms. 4.72 means how much you get? 3.28 ohms to 4.72 ohms. This is the range of resistance. Clear? Okay, this is question number 9. Concentrate, quick, note down. If it is given is parallel, then we can solve like this. If any number of resistance are given, you do like the 1 by R1 plus 1 by R2 plus 1 by R3 like this. If problem is given in percentage, you convert into absolute. Then you substitute like this. Again, if you want this one, you convert into percentage form. You also convert this into percentage form also. For example, I want to tell this answer in percentage. Then what is the percentage in, what is the percentage R, what is the percentage form of R, you tell me, plus or minus 0.72 by 4 into 100. Yes, how much you can get, you tell me. How much? Plus or minus, this is 72 na? 72 means that by 4. Then how much you can get? Plus or minus 18%. Error by true value into 100. Then you can write R equal to 4 plus or minus 18%. Like this also you can write. Understood? This question number 9. But it is asked in the problem only. Calculate resultant resistance and range of resistance. That may be in terms of percentage also. See the question number 10. Read the question, all of you. Okay, what it is given? Yes, a set of readings are measured as, what the readings are given? A set of readings are measured as 110.07 milliamperes. Yes, 110.02 milliamperes. Next, what it is given? Yes, 110.09 milliampere, 110.22 milliampere. Then what it is given? 110.19 milliampere. This is a set of readings given. Then you want to calculate range of error. This is a question asked. But I given how to calculate range of error na? What is the formula for range of error, you tell me? Yes, range of error equal to plus or minus S x maxima minus x minima by 2. This formula you know. Range of error equal to plus or minus x maxima minus x minima by 2. Yes, tell me, plus or minus, what is the maximum value in this case? Maximum is 0.22, 110.22. This is 0.22 minus, what is the minimum value, you tell me? This is 0.02 by 2. Then what you can get? Plus or minus 0.20 by 2. Then what you can plus or minus 0.10 milliamperes. This is the range of error. Here the set of readings are given. You calculate range of error, that is plus or minus 0.10 milliampere. X maxima minus, you take average also, that average will be cancelled. But no need to do that one, directly also you can solve. Plus or minus 0.1 milliampere. Quick to the problem. This is question number 10. See the question number 11, what it is given? Concentrate. Question number 11. All of you read the question. Four ammeters M1, M2, M3 and M4. Question number 11. Four ammeters M1, M2, M3 and M4. Yes. With the following specifications available, full scale accuracy as percentage of full scale. It is given as a percentage of full scale. What is M1 is given 20 plus or minus 0.1%. That is as a percentage of full scale. M2 equal to what it is given 10 plus or minus 0.2%. M3 is given as 5 plus or minus 0.5%. Okay. Then M4 is given as 1 plus or minus 1%. 1 plus or minus 1%. All are given in percentage. It is mentioned in the bracket. 1 plus or minus 1%. A current of 1 ampere is to be measured. A current of 1 ampere to be measured. To obtain minimum error in the reading, one should select the meter is. To obtain. That means you want to measure. We are measuring 1 ampere of current. We are measuring 1 ampere of current. Yes. To measure with minimum error, then which meter will be selected? Option A is M1, option B is M2, option C is what it is given M3, option D is given as M4. Then which meter should be selected? That you concentrate. That means the meter which gives the less error, that meter is more preferable. Okay, but this is given in percentage na. But if you want to compare the errors, means you convert into absolute form. Okay, then what this gives? Absolute error of, what is absolute error in M1? Absolute error in M1 is 20 into plus or minus 0.1 by 100. How much you can get? You tell me. This we get. This is 20 plus or minus. This is not 0.1%, sorry, this is plus or minus 10%. 20 plus or minus 10%. Okay. This how much you can get, to tell me? 20 into plus or minus 10 by 100. How much you get? Plus or minus 2 amperes. The error is plus or minus 2 amperes. Then what about M2? This is for M2. This is M2 is 10 plus or minus 0.2 by 100. This is 10 into plus or minus 0.2 by 100. 10 into plus or minus 0.2 by 100. Then how much you can get? Tell me. This is in the measurement of 10 amperes na. This we can get 2 by 100 means how much this? Yes. Is it correct? Is 0.2% or 2%? Yes, I think it is a 2%. It is also 2%. Is correct? This how much you can get? This is 2% means 2 plus or minus 2 by 100 means plus or minus 0.2 amperes error. M2. What about M3? You tell me. M3 5 into plus or minus 0.5 by 100. How much you get? This is 2.5 now. This how much? 0.025. 0.025%. This is 2.5 by 100. That is 0.025% error. What is the M4 you can get? 1 into plus or minus 1 by 100. How much you get? Plus or minus 0.01 error. Then this gives a plus or minus 0.01 error. M4. M3 gives plus or minus 0.025 error. Then what about M3 will give plus or minus 0.2 amperes error. M1 will give plus or minus 2 amperes. You correct this one please. Plus or minus 2%. This is plus or minus 10%. If any wrong is there. Okay. Then what is the, then by using among all this which is more accurate, you tell me. This error is 2 ampere. This error is 0.2 ampere. This gives how much? not percentage. This gives 0.02 ampere error. This gives 0.01 ampere error only. That's why which is more accurate? M4. That's why the best selection is M4 ammeter to measure the 1 ampere. This gives only 0.01. Clear? Like this we can solve. This question number 11. The remaining still some questions are there in workbook now. Then in the next session I will continue. Okay. Thank you.